In this module, we're going to look at three forms of a quadratic function. Specifically, this video is going to focus on vertex form. So we're going to be answering the question, what do quadratic functions look like in different forms? So let me remind you of what you should know already about quadratic equations. When I say equations, that means I'm just talking about one variable. This is where you should have an x squared somewhere as your highest degree or your highest exponent. So this is an example of a quadratic equation, and again, it is the x to the second power that makes it quadratic. What are the important points of a quadratic function? Well, function, now I'm talking two variables, so this is something I can graph on a coordinate plane. Well, I could have a parabola that opens upward or downward. And what are the important points that I talk so much about? Would be my zeros or my x-intercept, my vertex, which is going to be my minimum point in this one. Over here, the vertex would be the maximum point. Where it crosses the y-axis, this is also something that's super important, would be our y-intercept. Okay, so we're going to look at how do we actually find these when we're given different forms of a quadratic function. So standard form of a quadratic function would be f of x equals, or remember that's the same as y equals. We're going to have an x squared term, an x term, and then a constant term. So again, it's ax squared. Of course, it could be plus or minus bx, plus or minus c. This is standard form, so it's the same as standard form of just a quadratic equation, except now it's got a y. Okay, so what does standard form show us? Well, that first value, a, controls whether the graph opens up or down. Okay, so a tells us a lot. In this scenario, if there is a negative a, the graph will open downward. And over here, we would have a positive a value for it to open upward. You should have seen in your discovery in Schoology that if the absolute value of a is greater than 1, so if it's something like 2x squared, 3x squared, 4x squared, what happens to the actual graph? Well, it vertically stretches it and it gets narrower. The parabola gets skinny. I encourage you to go back and look at it in the applet in Schoology if you don't know what I'm talking about. The absolute value of a, if it's a fraction smaller than 1, like 1/2, the parabola actually gets wider. So let's answer some checkpoint questions. Does the function f of x equals 3x squared minus 4x plus 2 have a minimum or a maximum value? Well, how do I answer that? Well, it's all about a, okay? I'm going to highlight my a value. A is 3. So since it's positive, that means my graph is going to open upward. So my vertex, is that going to be a minimum value or a maximum? Well, that's the lowest it ever hits. So this has a minimum. Now we're supposed to write a quadratic function that has a maximum. Well, if it has a maximum, that means it's opening like this. So that means that my a value has to be something that's negative, like negative 5x squared plus 2x minus 4. Okay, which function has the widest graph and which one has the most narrow graph? Well, it's almost a little counterintuitive here. Remember, if it's a fraction smaller than 1, it's actually getting wider because your graph is getting like scrunched vertically, so it's wider. So let's look at all the ones that are less than 1. All right, so meaning the a value. So this is less than 1, and negative 1/4 is less than 1. And when I say, I don't even care about the sign, the fact that it's negative or positive, because I'm looking at the absolute value, so just the number part, 1/2 and 1/4. Well, which one would be the most narrow? Well, it's going to be the smallest one, so here is my narrowest. And now let's look at the ones that are greater than 1, because they will be wider. So I'm going to highlight the ones greater than 1 in green. So 3 is greater than 1, just the absolute value of it. 2 is greater than 1. This one here is exactly 1. It's just going to open downward. So the one that is the widest is the one that's the furthest from 1. It's going to be the -3 right here. All right, let's look at how we algebraically calculate a vertex, whether it opens upward or downward. The vertex is equal to the opposite of b over 2a. And then we plug that value in to get our y value. All right, so good practices start by identifying the values of a, b, and c. So they would be 3, 12, and -7. Just make sure that the problem doesn't get tricky and switch things around on you. So negative b over 2a means it's the opposite of b, which would be -12 over 2 times 3. So this would be -12 over 6, which is -2. All right, so it's an ordered pair. I know that now that my x is -2. How do I get my y? Well, I plug into my function, meaning I'm doing f of -2. So everywhere there is an x, I'm going to plug in -2 and type this whole thing in your calculator or do a little math. And I get -19 when I do this in my head. Hopefully I didn't make a mistake. Verify that please on your calculator. So here is the vertex of. We are at another checkpoint. So pause the video and see if you can do 4. Hit play when you're ready. So hopefully you started by identifying the values of A, B, and C. Make sure you keep the signs on it. The vertex is -b, or the opposite of b, over 2 times a. Opposite of b would be -8. Just a side note, if it was already negative, it switches to positive. Okay, over 2 times a, which would be -2. That gives me -8 over -4. Divide that and I get 2. So my vertex is going to be 2 comma something. How do I get that something? Well, if we have an x, we always plug in to get a y. So we're doing f of 2 is equal to -2. Just opening up parentheses, and I'm going to plug in 2. I'm going to do the math, and I get 3 when I do this. So there's your vertex. In number 5, we're going to look at a revenue function. So let's quickly talk about what revenue is. Revenue is the amount of money that like a business brings in. So we often use a capital R, and we'll say like R of X for a revenue function. Well, the money you bring in is equal to like the price per item times the quantity of items. So like if I'm selling t-shirts, I sell them at $10 a piece, I would do $10 times however many I sell. If I sell 50 of them, to figure out that the revenue I brought in is $500. Now that's not necessarily my profit, it's just the money I bring in. Okay, so a go-kart track has about 380 racers per week. So this is quantity. I'm going to highlight anything in quantity in blue. And charges about $35 to race. The owner estimates that there will be 20 more racers per week for every $1 reduction in the price per racer. All right, so we're going to write a revenue function. But I got to think about what my unknown is first of all. So I'm going to say X is my unknown like I normally do, but what does it represent? It's, well, they're changing the price. So it's the number of times the price is changed. Number of price changes. All right, so my revenue function, I'm going to say R of X is equal to, I open up 2 sets of parentheses, large enough to do a little bit of math here. So normally, okay, so if I do price first and quantity second, you'll see it flip-flopped. It doesn't really matter. You could do quantity times price. Just keep your numbers straight. So the price is $35 and 380 racers show up, right? 35 times 380. But then they figure out if they adjust it. How do they adjust it? Well, they're dropping the price, $1 reduction. So -1, but they don't just drop it one time. How many times do they drop it? We don't know. So 1 times x. What happens to the amount of racers? Well, the racers, more people show up. So I'm going to add how many? 20 each time they change the price. So plus 20x. Some things to notice. So in these revenue functions, I got one that's a minus and one's a plus. You will always have that. All right, so there it is. What I want you to do now, though, is change this to standard form. So you're going to need to do some distributing to get that done. So I zoomed in here to give myself a little more space. What I need to do is distribute the 35 to the two things in the second set of parentheses. So to change it to standard form, this is going to be 35 times 380. And that is 13,300. And 35 times 20x would be plus 700x. And now I need to distribute this -1 to both things. So this will be negative 380x and then minus 20x squared. Okay, so standard form here would be put the x squared first, so negative 20x squared. Going to combine my middle terms is positive 320x, and then it's plus 13,300. Okay, there is my revenue function in standard form. Determine the price that will maximize the revenue. Okay, so maximize. My A value is negative. What's that tell me? It tells me my parabola opens downward. So here's the highest it's going to get. So I need to find my vertex. All right, so what are we going to do? We're going to do negative B over 2A, which is equal to negative 320 over 2 times negative 20. Quickly do that math, and I get 8. So my x-coordinate is 8. How do I get my y-coordinate? I need to do r of 8. So if you just pick up your calculator and plug in 8, gives me 14,580. Okay, so let's just take a second and say what these two things mean. So x was my price changes. So this means if I change the price 8 times, 8 price changes will give me a revenue, because y, or the r of x is the y, is the revenue. But what does part B ask me? It says determine the price that will maximize the weekly revenue. Easiest way to get this, there's more than one way, is look right here at the beginning equation. The price was equal to 35 minus 1x. So if you just take this price expression right here and you plug your x value in, so 35 minus 1x, and you just found that x is 8 when it's maximized at the vertex, so you just plug it in to get 35 minus 8 is $27 would be my answer to part B. Now part C, what is the maximum weekly revenue? We have that already. That's in our ordered pair. We labeled it as the revenue. So if they change their price 8 times, they're going to maximize their revenue, bringing in $14,580. Okay, this next one's about Mrs. Houck and her Spartan race in Vermont last year. On the fire jump obstacle at the 2019 Spartan race in Vermont, Mrs. Houck's jump could be modeled by that function. Very similar to the jump of a red kangaroo, only with much more elegance and grace. Where x is the horizontal distance in feet covered by Mrs. Houck, and y is her height in feet throughout the jump. If the flames reached a height of 4 feet, did Mrs. Houck complete the obstacle uncharred? Well, if she's jumping, her path is going something like this. Okay, so what do we need to see? Does her height get up to a y value of 4 feet? Okay, does it reach 4? If it does, she didn't get burned. So what do we need to do? Let's find our vertex. So when I plug in, I get an x value is 14, and I now have to plug in 14 in for my x to get my y. And when I do that, I get y equals 6. So if this is the vertex, she reached a height of 6. That means she would have made it over the flames without being charred. All right, last quick part about standard form. How we find a y-intercept. Well, the beautiful thing here is this works just a lot like it does with linear equations. So identify the y-intercept right here. Well, where does it cross? Okay, my y-intercept is 0, 5. Look at the equation. Do you see anything? Notice anything? What about this one here? What's my y-intercept? It would be 0, -2. Do you see anything? I'm hoping you do. When it's in standard form, the c value, do you see it, is the y-intercept. Why is that? Because you're plugging in 0. If you plug in 0, you're going to be left with just the constant.